Number 12 is a question that also involves some knowledge that we obtained in Unit 7. Karen's recursively generating a sequence, and we've got kind of a nice recursive rule written. And Karen knows that the fifth term is 407, but she doesn't know what the term she started with is. So, what we need to do is kind of work backwards because in recursive rules, the only way you can know the next term is to know the term that comes before it. So, we'll have to work backwards here. We're going to start with 407, that's the fifth term. We're going to plug it into this nice recursive formula that Karen wrote for us. 407 is equal to the term before, so if that's the fifth term, the term before would be the fourth term, plus 3 times the term number that we're on the fifth term right now, minus 1. 15 minus 1 is 14. If I subtract that to the other side, I get 393. So that's what the fourth term is equal to. So now I'll have to do this again. 393 is equal to the term before it, the third term, plus 3 times the term number that we're on, the fourth term. 393 is the fourth term, minus 1. 12 minus 1 is 11. If we subtract that over, we get 382. That's going to be our third term. So we'll have to do this again. 382 is equal to the term before it, the second term, plus 3 times the term we're on the third term, minus 1. 9 minus 1 is 8. When we subtract that over, we get 374. That's the second term. We're almost there. We have to do this one more time. 374 is equal to the term before, which is a sub 1, the first term of this sequence, plus 3 times the term number that we're on, which is 2, minus 1. 6 minus 1 is 5, and when we subtract that over, we get 369. That's the first term of this sequence. Choice D. Number 13 goes back to something that we talked about with functions, or we could also relate this to conics in Unit 5. This particular equation is actually the equation of a parabola. It's just not quite in that standard form that we're used to. We'd have to subtract 8 over to the other side. This question's asking us the distance between the y-intercepts, and really what we need to know here is how do you find y-intercepts? In order to find y-intercepts, you're going to plug in 0 for x and solve for y. Now this problem's already giving you kind of a hint because it says between the x-intercepts, and intercepts is plural, so that means we better have 2 when we're solving. When I plug in 0 for x for this original equation, 0 plus 8 on the left is equal to 2 times y plus 3 squared. So over on the left, we just have 8 is equal to 2 multiplied by y plus 3 squared. Divide both sides by 2. 4 is equal to y plus 3 squared. And now we square root both sides. The square root of 4 is a nice even number 2. But since we physically took the square root of a value, we need to remember plus minus in front of it. Now we have kind of 2 branches of solutions when we subtract 3 over to the other side. Plus or minus 2 subtracting 3 from that, we have 2 answers. Positive 2 minus 3 is equal to negative 1. Negative 2 minus 3 is equal to negative 5. Now the distance between these two is 4. Number 14 deals with a problem that we talked about back in Unit 2, rational functions. What we need to do here is multiply all the numerators by the least common denominator. But before I get ahead of myself, let's state the excluded values. These are the values that make your denominator 0. So x cannot equal 1. We'd have an undefined value in our denominator. We're going to multiply all the numerators by the least common denominator. So x multiplied by x minus 1. 3x multiplied by x minus 1 over that denominator. and x plus 2 multiplied by x minus 1 over that same denominator. When we do this, we're able to simplify quite a bit. We get rid of our fractions. So all we're left with is x times x plus, or x minus 1, sorry, plus 3x is equal to x plus 2. Now all we have to do is distribute and combine like terms. X squared minus x plus 3x is equal to x plus 2. When I combine on the left, I get a positive 2x. And since I've got a squared term and a linear term, I'm going to have to move everything over to one side of the equation. X squared plus x minus 2 equals 0. This factors nicely into two binomials that will factor into x plus 2 and x minus 2. Sorry, x minus 1. Set each factor equal to 0 and solve. These are the two solutions that we get, negative 2 and positive 1. But remember, positive 1 is an excluded value, so that will not work. The only solution that works in this particular case is negative 2.